Hello everyone, welcome to all in this session. So now in this session, I'm going to discuss with you some question from friction or previous year question of ISRO exam. So let's see one by one. So in the first question, you can see a block of weight 981 is resting over a horizontal surface. The coefficient of friction between the block and the horizontal surface is given, that is 0.2. A vertical cable attached to the block provides partial support as shown in the figure. A man can pull horizontal with a force 100 Newton. So this force is given 100 Newton, and here we have a tension. What will be the tension in the cable if the man is just able to move the block to right side? Means this block is trying to move along this direction. Then obviously against this motion, the surface may induce here. Sorry, frictional force induced here, and let us say this is FF. So if I draw a free body diagram of this block, so can I represent it is looking like this? This is a block, and in this block we have tension in this direction, and its own weight is acting in the downward direction, which is W, which is equal to 981 Newton. Yes or no? And this block is pulled by a force, let's say this is P, which is equal to 100 Newton, and the frictional force may induce here. Yes or no? This is FF. And obviously along with, since this block is having this force, so one normal reaction may also act in the upward direction. Yes or no? So now for equilibrium condition, if we can apply equilibrium condition, that is summation of horizontal force and vertical force is equal to 0. So let's say if I write summation of vertical force equal to 0, so can I say this is N plus T is nothing but this is W, which is equal to 981 Newton, and this is equation 1. And similarly, summation of horizontal force is equal to 0. So simply we can say frictional force minus P is equal to 0, or simply you can say friction force is equal to P, and P is already given here, that is 100 Newton. And what about FF? Friction force is nothing but it can be written as mu times of N, that is normal reaction, is equal to 100. So from this expression we can get N, which is 100 over zero point 0.2, because coefficient of friction is already given 0.2. So simply here we can get this is 500 Newton. Yes or no? So after getting this normal reaction, what we need to do? So can I say from equation 1, so the T is nothing but this is 981 minus N, that is 500, which gives us 481 Newton. So the correct answer is option C. So this is very simple question. Yes or no? Okay, so let's see another question. So you can see in this question here we have a solid block of weight Q is resting on a flat floor. This is a block, and this is a solid block. A weight of Q is Q kg is resting on the flat floor, a smooth cylinder. You can say this is a smooth cylinder. A smooth cylinder means there is no friction between cylinder and the wall. Yes or no? Weighing B, cylinder B, weighing P kg is placed between the solid A and the vertical wall as shown in the figure. The friction between the cylinder wall and the block A is negligible. The coefficient of friction between the block A and the floor is mu. The minimum weight P required to disturb the block A is. Correct. So what you need to do? First, we need to find the reaction between block A and the cylinder A. Yes or no? So cylinder B. So simply you can see here, if I draw a free body diagram for this cylinder, so can I say here in this cylinder we have a normal reaction somewhere here, and its own weight which is acting in the downward direction, and one more reaction is acting like this. Yes or no? So if I intersect the line of action of all these forces, so can I represent it as looking like this? Yes or no? So this is nothing but this is a reaction at the ball, sphere and wall. Yes or no? So let's say this is RW, and this is a reaction induced applied by sphere on the block A. So can I say this is Ra, and this is weight of the cylindrical cylinder, that is P. Is it clear? And obviously you can see the angle theta is given here. So from vertical, actually from vertical, okay, so you can say here, if I draw a line like this, parallel to this line, is it clear? Then you can see here, and similarly if I draw vertical from it. So now in this case, you will get this angle is theta, yes or no? This angle is theta. This angle is theta. Is it clear? Which is already given here. And obviously if this is theta, then can I say this is 90 minus theta? And obviously this is perpendicular to this. Yes or no? So simply we can say this is 90 minus theta. Even if it is 90 minus theta, then this will be a theta. So this angle is nothing but, can I say this angle is nothing but this is 90 plus theta, or you need not to apply Lamy's theorem. You just, by resolving the force, we can get the answer, yes or no. If this angle is theta, then simply you can say this angle is also theta. This is alternate angle, yes or no. And if this angle is theta, then this one is 90 minus theta, then this one is also theta, yes or no. So simply if you resolve this Ra force, so can I say summation of horizontal force is equal to 0, yes or no. So Ra, its horizontal component is nothing but this is Ra cos theta, yes or no, is equal to Rw yes or no. And similarly if I say its vertical component, summation of vertical force is equal to 0, so simply can I say this is Ra sin theta is equal to P. So from this simply we get Ra is equal to P by sin theta, and I am not interested in determining Rw because we need Ra only, yes or no. So let's say this is equation 1. After getting Ra, so simply you can say if I draw a block which is looking like this is a block, is it clear? And this Ra is nothing but this Ra is acting somewhere here like this, yes or no. This is Ra whose value is P over sin theta, P over sin theta, yes or no, which is perpendicular to this surface. Ra is acting perpendicular to this surface, yes or no. Is it clear? And its own weight is nothing but it is acting downward. So let's say this is Q. And obviously due to this force, this box is trying to pull along this direction, yes or no. So the friction force can be act here, yes or no. Is it clear? And similarly, can I say along this direction we have normal reaction, yes or no. And similarly if you resolve this force like this, so here we can get two components. And what about angle? So if I draw a line parallel to this, so can I say this is 90 minus theta? Why? Because this angle is theta, so this one is 90 minus theta. If this 90 minus theta, then simply it can be written as theta. And if this is theta, then simply we can say this is Ra cos theta and this is Ra sin theta, yes or no. So again if you apply summation of vertical force is equal to 0, so simply we can say Q plus Ra sin theta is equal to n, and actually we need to determine n, yes or no. So what about n? Q plus Ra. Ra is given, that is P sin theta into sine theta. So simply here we can get n is equal to q plus p. And let's say this is equation 2. Is it clear? Okay, so now you can say here, so next we need to write summation of vertical force is equal to, sorry, horizontal force equal to 0. So horizontal force is nothing but, can I say, you can say here, friction force is acting like this, and friction force and this Ra cos theta is, both are acting in opposite direction, yes or no? So Ff is equal to Ra cos theta, yes or no? Ff cos theta. And what about Ff? Ff is nothing but this is mu times of normal reaction, which is Q plus P. And what about Ra? Ra is nothing but this is P sine theta into cos theta, yes or no? So from this we can say P is equal to tan theta into mu into Q plus P, yes or no? So if you simplify this expression, because we need P only, yes or no? So simply you can say here P minus mu tan theta into P is equal to mu tan theta into Q. So simply P can be written as mu tan theta into Q over 1 minus mu tan theta. Yes or no? So you can say which option is right. Mu tan theta q over 1 minus mu tan theta. Yes, option B is the right choice. So like this you can solve this problem. So this is very simple question. Our objective is we need to calculate n for solving, for determining p. Yes or no? So first you draw a free body diagram for this cylinder, and after that you need to draw a free body diagram for the block, and then you can find the answer. Yes or no? Okay, so let's see another question. A block weight 100 Newton is resting on a plane inclined horizontally as shown in the figure. What horizontal force P is necessary? What horizontal force P is necessary to hold the body from sliding down the plane? Correct. So obviously this block is trying to slide along this direction. Yes or no? So obviously frictional force is acting in the upward direction. Yes or no? So how we need to solve, how to solve this question? So you can see here, if I draw it's a free body diagram, every time you need to draw a free body diagram. So this is a block which is already rested on the inclined plane, yes or no? And this is horizontal surface, and from this horizontal surface it makes an angle 45 degree. So obviously its own weight is acting downward, one force is acting like this. So obviously you need to resolve this force parallel to this surface, and one normal reaction is acting somewhere here. And if you resolve this weight, its own weight, then it is simply written as, let's say if this is 100 Newton. So you can see, dear students, this one is nothing but this one is P. Is it clear? Sorry, theta. So simply we can say this is 100 cos theta and this is 100 sin theta. And similarly, if this force is P, this force is P, yes or no? Correct? So if I extend this line, then obviously this surface is parallel to this and this surface is parallel to this. So can I say this angle is also 45 degree? Yes or no? And theta is nothing but, let us see, this angle is theta. So simply can I say this angle is also theta? So this force is nothing but this is P cos theta and this is P sin theta. Yes or no? Is it clear? and the frictional force, obviously frictional force is acting along this direction, correct? So now you need to resolve all the forces along the n. Normal reaction is equal to 0. So simply here we can get n is equal to p sine theta, which is acting in the downward, plus 100 cos theta, which is also acting in the downward direction. Yes or no? And let's say, suppose this is equation 1. Obviously theta is 45 degrees, so don't worry about this. I will change it, correct? Next, summation of vertical force is equal to 0. Sorry, not vertical, simply I can say summation of all the tangential forces, tangential to the block, tangent to the block, is equal to 0. So can I say friction force is nothing but this is 100 sine theta minus p cos theta. Yes or no? So this is equation 2. So what you need to do? You need to calculate horizontal force P, and mu is given here. Yes or no? So instead of Ff, can I say mu times of n? N is nothing but this is P sine theta plus 100 cos theta is equal to 100 sine theta minus P cos theta. So by simplifying this equation, you can see mu is nothing but this is 0.25 into P sine 45 degree, and let us say we move this term in the left side. So here we can get P cos 45 degree, which is equal to 100 sine 45 degree minus mu, that is 0.25 into 100 into cos 45, correct? So when you solve this expression, then you will get the P. So I am directly writing here P is nothing but here we can get 60 Newton. After solving above equation, we can get P is equal to 60 Newton. So this one is the right answer. So option C is the right choice. Is that clear? A body of mass 10 kg is initially stationary on 45-degree inclined plane. You can see this is a mass which is inclined at inclined plane, which is inclined with 45 degree, and let us say this angle is theta. Is that clear? Student fair, the coefficient of dynamic friction, you can see here we have dynamic friction which is equal to 0.3. So let's see, first if I draw its free body diagram. So simply if I draw here, correct, then obviously one force is acting somewhere here, its own down, its own weight, and now you need to resolve this force parallel and perpendicular to this plane. Yes or no? So obviously this is nothing but, let's say this is mg. So this is nothing but this is mg, and what about this angle? This is theta. So mg cos theta, this angle is theta. So this is mg sin theta. And obviously this block is trying to move along this direction. So frictional force act here, and this is kinetic friction. And let's say this is n. So you can see if I write summation of normal force is equal to 0 for determination of n, so simply can I say n is nothing but this is equal to mg cos theta, and what about m? This is 10. What about g? This is 9.81, and what about cos theta? This is cos 45 degree. So from this you can calculate n. This is 98.1 by root 2. Yes or no? And let's say this is equation 1. So now you need to calculate kinetic friction force. Correct? So kinetic friction force is nothing but kinetic coefficient of friction into normal reaction, and this is 0.3 into 98.1 over root 2. So this is kinetic friction force. Yes or no? So you need to calculate net force, F net force along tangential direction, because this body is in motion. Yes or no? So tangential direction must be equal to mass into acceleration. Yes or no? And what about F net? F net is nothing but, you can see from this figure, a downward force mg sin theta is acting and this kinetic friction is acting in the upward direction. So net force is nothing but this is mg sin theta minus ffk is equal to m into a. So from this you need to calculate acceleration. And what about m? This is 10 g, that is 9.81 sin 45 degree minus ffk, which is 0.3 into 981, sorry, 998.1, not 981, over root 2 divided by mass, that is 10 kg. So from this you will get 981, 9.81 by root 2 into 1 minus, this is 0.3 by 0.3, sorry. And if you solve this, then you will get acceleration is equal to 4.94. Correct? 4.94 meter per second square. And let me see, this is 0.3, 98.1, or simply you can say 10 into 9.81 by root 2. So 0.3 into 10 into 9.81 by root 3. So let me see, if I calculate, then how much we get? 4.85, correct? Meter per second square. And once you get acceleration, then what you will need to do, then you can see, as you know that we need to find out displacement, yes or no? So final velocity is given, initial velocity is 0. So can I use this relation? So s is nothing but this is v square over 2a, and here u, initial velocity is 0. So v is already given in the question, that is 20 meter per second square. So 20 square over 2 into 4.856. So after solving this, here we can get a 41 meter distance. So option C is the right one. So from this question you need to actually calculate acceleration, and once you get acceleration, then by using this you will get the displacement, yes or no? Okay, so let's see another problem. So a block of cross section 4 by 3 meter size of 20 kg mass rests on a flat horizontal surface as shown in the figure below. If the coefficient of friction between the block and the surface is 1 by 4, means 0.25, the force F which will cause block to move in approximately given by, yes or no? Then you can see, if I resolve this force, then can I say here we can get F cos 30, and similarly here we can get F sin 30. And if I draw its free body diagram, then simply you can say here we have one force, here we have one force, yes or no? This is F sin 30 and this is F cos 30. Yes, and its own weight is acting in the downward direction, that is 10 20 kg. And let us 20 kg, no need to convert this force into this weight into mass into force, no need to convert it, correct? Because you can see in the question we have kgf unit, and obviously the normal reaction acting in the upward direction, yes or no? And obviously due to this force, this block is trying to pull along this direction, so the friction force is acting here, correct? So what we need to do, summation of, let's say if I say vertical force is equal to 0, so can I say this is F sin 30 plus n is equal to 20. So the normal reaction is nothing but this is 20 minus F sine 30. Yes or no? Correct? So now for motion of the block, for motion of the block, for motion of the block, this F cos 30 component must be greater than the friction force. Yes or no? So this is F cos 30 greater than, what about F? This is mu into, and mu already is given. This FF is nothing but this is mu, which is 1 by 4 times, and n is also given, that is 20 minus F sine 30. Yes or no? So if you simplify this, then you will get F cos 30 plus F by 4 sine 30 is greater than 1 by 4 into 20. So from this you need to calculate F, and after solving this, we can so you can see here we can get, you can solve it, and along with this you can also calculate moment about O. Yes or no? If the coefficient of friction between the block and the surface is 1 by 4, the force F which will cause block to move is approximately is given by, correct? So what we need to, if the coefficient of friction between the block and the surface is 1 by 4, the force F which will cause block to move, yes, you need to calculate force F. So let's see, if we simplify this expression, then what we will get here. Okay, so this is the condition at which this block can move. Yes or no? So now let's see, for equilibrium condition we can also write moment about O must be equal to 0, and if you write this equation, then simply can I say this is F cos 30 into 4, correct? F cos 30 into 4, and obviously this F sin 30 is passes through this origin O, so no need to write, minus 20 into this length is 3. So can I assume this force is acting at the center, so this is 3 by 2, this is equal to 0. So after solving this, here we can get F is equal to, so 30 over 4 cos 30. Yes or no? 30 over 4 cos 30. So simply here we can get 8.66. 8.66. Correct? F is nothing but this is 8.66 kgf, or simply we can say, F is equal to 8.7 kgf. Yes or no? So the correct answer is option D. Even you need not to write this expression. Correct? Is it clear? Directly by applying this you can get the answer. Okay, let's see another problem. If the figure shown the minimum ratio of mu1 by mu2 so that the masses moves together with the application of force F is it clear? So how to solve this question, you can see first I need to draw a free body diagram of both the sections. So let's say if this is considered as block 1 and this is block 2. So if I draw free body diagram for block 1, so obviously its own weight is acting downwards. So let's say this is 5 kg. I'm not converting this weight in this mass into force, and this is normal reaction N. And obviously one force is applying to pull this block is F, and since this block is moving towards the right, so frictional force is acting somewhere here. Yes or no? Let's say FF1, which is nothing but this is n times of mu1. Yes or no? This is n times of mu1. Correct? So this is free body diagram of block 1. And from this, can I say n is equal to 5 kg? And what about F? FF1, this is 5 kg into mu1. Is it clear? If the figure shows the minimum ratio of mu1 by mu2 so that the masses moves together with the application of force. So we can get FF1 like this, yes or no? Similarly, if I draw free body diagram for block 2, this is block 2, then it's here the total weight is acting 10 plus 5, and the normal, if I talk about normal reaction, this is N. And if this friction force is acting like this, then obviously block 1 is trying to pull this block along this direction by applying a friction force 1, and obviously in between block 2 and the surface we get a friction force like this is FF2. So what about N? Let's say this is N2 and this is N1, correct? So N2 is nothing but this is 15 kg. So if I say this is FF2, then obviously it can be written as mu2 into 15 kg. Yes or no? So when both the blocks can move, the question is this: when both the blocks can move, so simply we can say for the motion of both the blocks simultaneously, what we can say, if FF1 force, this FF1 force is greater than FF2 force, then obviously bottom block can move, yes or no? And similarly from this, can I say this F force is greater than FF1, then obviously this block 1 can move, yes or no, relative to block 2, yes or no? But we don't want this kind of motion, yes or no? So I am only interested for the block 2. So if I apply this condition, so can I say this is nothing but F, what about FF1? This is 5 into mu1 is greater than 15 into mu2, yes or no? So from this mu1 by mu2 is nothing but, and we also need to calculate mu1 by mu2. Mu1 by mu2 is nothing but this is equal to, greater than equal to 15 by 5, which gives us 3. So which gives us mu1 by mu2 greater than 3. So this is the answer. So option D will be the right answer. Okay, so what about this? Next you can see an elevator weighing 100 kg, 1000 kg attain an upward velocity of 4 meter per second in 2 seconds with uniform acceleration. Let's see, if I draw an elevator, this is an elevator weighing 1000 kg. So its weight is acting in the downward direction, that is 1000 kg. And if we apply, okay, G is given, that is 9.81. So I am using, sorry, 9.8. Correct. So this is the net weight acting. elevator weight is 1000 kg attained and upward velocity. Yes, it is moving in the upward direction with velocity 4 meter per second in 2 seconds. T is equal to 2 seconds with uniform acceleration. This is very important information, uniform acceleration. But because when we have uniform acceleration, then we can able to apply law of motion, correct? The tension in the supporting cable, let's say this is a cable in which we have tension T, will give, so you need to calculate actually T. So what we need to do, we need to calculate T, yes or no? So can I say net force is nothing but this is a T minus this 1000 into 9.8, which is equal to mass into acceleration, yes or no? And what about acceleration? So you can see these informations are given here. So can I apply V is equal to U plus AT, Newton's first law of motion? So from this we can get A, because U is not given. So can I say this is 0 and V is 4 meter per second, and this velocity will be achieved at a time 2 seconds. So 4 by 2. So this is 2 meter per second square, yes or no? So once we get acceleration, so simply you can get here A minus 1000 into 9.8 is equal to mass is given, that is 1000 into 2. So from this if we see, this is 2000 minus 9, sorry, this is plus 1000 into 9.8. So by solving this, what we will get here, you can see a T is equal to this is 98 9800 plus 2000. So can I say their sum is nothing but this is 11800 Newton. So the correct answer will be option D. Okay, so let's say another problem. An elevator has a mass of 5000 kg when the tension in the supporting cable is 60. You can see this is a elevator and its own weight is 5000 kg into, let's say if I multiply with 9.8 Newton, yes or no? And a cable is provided here which is having a tension is equal to 60 kilonewton, so 60 10 to the power 3 Newton. Then acceleration of the elevator is nearly, so you need to calculate how much acceleration we have. So the elevator has mass this, when the tension in the supporting cable is 60 Newton, the acceleration of the elevator is nearly. So you can see net force acting on the elevator is nothing but this is T minus 5000, sorry, into 9.81 is equal to mass into acceleration. Can I use this expression? So acceleration is nothing but tension is already given 16 to 10 power 3 minus 5000 into 9.81 over mass, which is 5000. So when you solve this expression, then here we'll get, I am directly writing, so don't worry. Okay, so I need to calculate, don't worry. 60,000 minus 5,000 into 9.81 over 5,000. So here we can get 2.19 meter per second square. Now the question is whether it is acting in the acceleration along the upward direction or in the downward direction. Correct? You need to find this. Then what about this force? If I take this, then this is 50,000 Newton force. Yes, sorry, 50,000 Newton force, and this is of 50 kilonewton force, and this is 60 kilonewton force. So tension is acting in the upward direction. Yes or no? And you can see in the previous question, similarly, previous question. In this case, the net weight is acting, that is 9800, and tension will be 11800. So in this case, the acceleration is acting in the upward direction, yes or no? So simply here we also get a acceleration in the upward direction. Is it clear? So D will be positive. Correct? Okay, so next. So I think it is in okay, so this is enough for today's class.